You saw enough oil gushing in the first black gold or black death. We'll show beaker tests and talk about luck. Test wells are a gamble, and more fail than succeed. BP's deep water test well struck gold, but BP failed to remove it, to be replaced by more expensive production wells capable of the control needed for production. The shutdown was a disaster. Petroleum in transit can separate into components. The gas exploded at the surface, killing workers, and the pipe fell to the ocean floor, apparently broken into 3 places, and these breaks began leaking petroleum components in huge amounts. Our beaker experiments are an introduction to what should have been done the day after the first disaster. With bad luck, we should be prepared to act the day after any more serious discharges of petroleum. The oil scattered over the surface by the 3 leaks should have been swept together in a big pool to wait for a tanker to come and take it to market. Sweeping doesn't involve the oil, only the water. Water is removed for a few meters below the surface to draw the oil into its place on the surface. To collect spilled oil into a pool requires a 3-dimensional circulation similar to that we show in the beakers, with some differences. We can obtain it by just using one impeller to pull the water out at the bottom underneath the oil, or we may find it's more effective to use 2 impellers, one in the surface and one underneath. The one in the surface would be pushing water in. It would create a circulation similar to that what scientists call deep water waves. When deep water waves are slowed at the bottom, they break and form shallow waves. Big deep water waves made by distant storms become smooth and almost unnoticed as they travel the deep ocean and break as monster waves on shallow ridges 60 meters underwater. Monster waves 20 or more feet high are rare, but surfers all over the world know in advance when and where to congregate to try their skill with monster waves. This section, which includes real wave behavior, I would like the help of a surfer who has ridden the monster breaking waves and has a spectacular video of it. But I would also like an explanation of the wave's history as a deep water wave coming to wherever it was, as well as to describe the skill needed to ride the monster wave successfully. Today we will look at beaker experiments more carefully and in detail, so we know how to move from the beaker to the ocean in order first to collect the surface, the water, together and use the results with water to predict the collection of oil on a water surface. I've learned a lot from watching beaker tests, which show unexpected traits. If you have access to a magnetic stirrer and beaker, you may wish to join in the experiments. Before we consider the huge waters of the Gulf, we might consider how big is a big pool of oil. Let's take 1 million gallons of oil. This table gives first a line of my conversion constants between US gallons, cubic meters, and barrels, and then the results for the radii of circular pools of oil at an average depth of 1 meter deep, 10 centimeters deep, and 1 centimeter deep. The pools aren't nearly as big as you might think, and the smallest might be inconveniently small for boats. If the tankers are slow in coming and the oil accumulates to 100 million gallons, radii increase by a factor of 10. This episode of Black Gold or Black Death is non-technical, show and tell plus hand waving. The third episode will be technical and give a foundation for judgment. When conditions in the beaker are stable, it's difficult to see the water's motion, but you've also watched conditions when oil is poured into water and droplets move with the water to indicate the movement until they coalesce into a core that directs the water movement. When we changed the water level by pouring water into the experiment, the yellow-colored oil broke up into tiny droplets which showed water motion again until the droplets coalesced. We'll start a third experiment where additional oil is covered by brilliant green and is added to the yellow pool and produces a dark fraction at the top. The green is soluble in both oil and water. We first see little effect because the combined oil pool is almost stagnant. The experiment took many minutes. When the green eventually reaches the water-oil surface, it passes through to brilliantly color the water. You will see it falling from the oil tip and forming tiny moving threads of green. Eventually these threads will color all the water green. Let's fill the waiting time with hand waving. First to suggest the motions we've seen in beakers, and then to show what we really want to happen in the ocean. For water in the beaker, I wave the tips of my fingers around in circles. Out at the bottom, up at the wall, into the oil pool, down along the oil surface to the tip, and down further to the magnetic bar, and out along the bottom of the beaker again. We have been watching what's happened in the beaker as a prelude to what we hope will happen or expect to happen with the actual pool, using the water to pull the oil together. Let me just review first with the tips of my fingers what we've been watching in the beaker. We've had water coming at the bottom, coming up to the top and circulating around a little core of oil that's pulled down. What I want to do is to extend this out to the dimensions of the oil pool. In other words, out 20, 50, 100 meters. Now you can see my hands out at the end doing exactly the same thing as before, except that they're all to the outside. The water is not moving except primarily at the edges, meters away. I would like to use my hands for a different purpose, as the impellers that will be pulled by the cables, which might be my arms, but we're not discussing the cables. What I want to do is, you'll notice I have a right hand and a left hand, and I will have right and left hand impellers. I may use both, I may just choose the one. I'll have the right-handed impeller that will be underneath the pool, throwing the water out from under the pool. And if we use the left one, we'll have it at the surface, pushing the water in. Together, what they will do is they will create a circulation that's like this. If we look at the right-handed impeller, it's moving along my palm through the water, and as it goes through the water, it will throw the water over to the left-hand side. The direction it throws it, the angle at which it throws it, will depend on how it is shaped. You can either throw it directly out, you can throw it behind, or you can throw it in front. We can do it so that we get no circulation except in the motion, in the vertical direction, or we can have it so that there's both circulation in the vertical direction and rotation, one direction or the other, in the horizontal dimension.